Okay, good evening. It is day 41 or 2. 1 or 2, I forget. I think it's 2. Anyways, um, I'm starting late today because I did kind of stay up pretty late last night. Woke up pretty late, and then I cleaned up my room. I had to do some stuff. I had my PC on my desk because when I first moved in, I didn't I forgot the screws to actually mount. I mount my PC under my desk. Um, so I just did that this morning, or not this morning, more like this afternoon. And then I went out and got some groceries and you know just did some basic work. But um, here now, the Texas Longhorns playoff game is at 7:30, so that's when this video is ending, sometime around there. So yeah, so we're trying to get as much done as we can before then. So the actual plan, I figure, is another two leak codes, and then working on the CLI project. Um, I know last time we got to like, I mean, we're still at like, what questions do we need to ask to be able to do this? And then I want to look into and maybe like brainstorm with ChatGPT, like some ways that we can, you know, approach this because like I feel like for this to be, I don't want to do anything where it's like using large language models or shit like that, right? If I were to give it to like like a large language model, the file structure, and then say generate, um, generate the files and stuff like that. There's so much like it's just not reliable enough, right? I need this to be pretty static and hard coded, right? I don't think I can do any outside LLM. Maybe there is a place for that. Maybe there's some place for that, but it's like not for making the code files at the very least. And I honestly rather ask like five more questions than have to integrate an LLM into this tool, and it just adds complexity. It adds cost. It adds um, room margin for error. There's a lot of stuff that's not good with adding that. So I think I'm gonna stay away from that and just really try to work on what questions need to be asked. Um, and I think that could also just be trial and error, right? Like right now, like take the questions I have right now and see, okay, can I generate the Docker images in the compose file and run it? Can I do all of that with the questions I have now? If so, maybe I don't need to ask more questions, right? Um, then try it with different projects, see if it works on that. And if it doesn't, do I need to ask more? And once I get to a point where it is working, go back and be like, okay, can I remove stuff, right? Do I need this question? Can I infer this question? Um, yeah. So, can I make a statement like when you load up the CLI thing? Can I make a statement like be in your root directory so you don't have to define the root directory? I don't know. We'll see. Um, but yeah, and then they'll also I have to make documentation on it, which that's also a good learning thing. I'm learning how to properly document a publicly accessible tool, right? Um, so yeah, so that's the plan. Two leak codes and then working on CLI project. So um, I applied to another um, actually I applied to, so you can see, actually we can just go through the history. So like I applied to um, like about like 50 internships like early on in the year. And then I kind of fall off after like 56 for like a month, and then throughout um, October and November, I applied to like another 30. Did pretty much nothing through December, and then I've applied to about another like 50. Um, this is like horrible. Oh yeah, I wanted to try putting camera down here today, right? that? I don't know. Because like this does block like important stuff, especially like okay, if I'm on like here, right? I go to backtracking. It like covers that up, but then also if I go here and we end up looking at like test cases, I'm just covering up test cases. Maybe like down here is good. Actually, bottom left could be kind of nice. I'll try bottom left today. I'll see how that goes. Anyways, I was showing this. So yeah, so it was like the 50 early on, another 30 up until December, and then another 50 this month. So the only thing I got that's actually something I need to do. It would be nice to do this like actually on recording, but I don't think it's definitely not allowed. So I got a coding assessment for IBM for an internship. Um, I actually got reached out to by a recruiter. It was like a handshake, probably automatic thing, and that's why I applied. And it's probably also just an automatic coding assessment, so nothing special. Automated message into an automatic coding assessment, um, but it's an update, I guess. So I'll be doing that this weekend, and then sending out. Hopefully this weekend, sending out another 50 applications. It'd be nice to round that off at like 200 applications and just keep going. I'd like to at least be doing like 50 applications a week from here on out. The only problem is like an issue I ran into in the fall was honestly like there was a point where like it felt like I'd kind of just like had nothing else to apply to. Um, like when I was like scrolling Handshake, I either already applied or it didn't apply to me, or it was like um it felt scarce. But right now, like scrolling, the only issue now is it's like a lot of the postings on there are from like a month ago, from like early-ish December maybe. Um, there are new ones within like the past week or two, but it's like I don't even know if it's like the ones that you apply externally on their website, um, that were like listed a month ago. It just doesn't even feel like I don't know. Like if the description matches me pretty well, then I'll apply to it. But like other than that, I don't even know if it's worth like the time. I mean, I guess at this point I've gone through 100, 150 applications and I've gotten not even a single phone screen, so it's probably worth the time to just do everything I can. But anyways, let's get into LeetCode. Okay, combination sum. Before I do this one, I want to look at this one again and what this even was. Um, given an array of distinct nums and a target, an integer target, return the list of all unique combinations. So what was this again? It was a DFS. If total equals target, this ran, right? Yeah. So depth first search, if the total equals target, append current dot copy. If I is greater than or equal to the links to them or return. Ugh, this is nasty. Nasty word. I remember last time when we did this. Um, also, this is like last time when we did this, I had to um what am I trying to say here? We watched the video and I still didn't get it. Like this one for some reason just not getting it. Anyways, let's look at the other combination sum. Or maybe I just skip this one and go to permutations. Given an array nums of unique integers, return all possible permutations. You may return the answer in any order. Got it. Wait, is a permutation really the same size? I thought a permutation could be like one or one and two or two and one or any of that. Is that really not the case? Let me go get a drink. I'll be right back. But like, actually, let me look at that first. Um, is a list in Python a permutation only if the other list is the same length with same elements, only different order, or can it be smaller? Okay, got it. I mean, like, no shit, because it obviously would show it here, but just making sure. Okay, so that's nice that we know that so we know we're gonna have, I always like just doing a return array, right? I'm just gonna append it to here, each match that we get. Um, and so obviously we want, I'd assume, can you have a set of tuples? Anyways, I need to go 1 second. I'm back. Got me a blackberry mango seltzer. Mmm. Said it was new. New. I'm new. Okay. Given an array nums of unique integers, we already went through all this. Okay. So, what's the approach here? If I had to make every single combination of a list, what would I do? Well, there is always the idea of building out a tree, right? With every element. So you start root node is fucking nothing, right? It's just the root of everything. Then from this root, you have the original array. And then from each element in the original array, right, which would be the first element of your new array, you would do. Hold on, let me visualize this a little bit. A little TL draw. A little TL draw. Delete that. Okay. So we have our root node, right? And let's just say we have 1 and 2, right? The original array is just 1 and 2. Right? So what would every permutation be of this? I guess actually doing the examples better because this would be like fucking nothing. So we have 1, we have 2, and we have 3. Okay. So this is itself a permutation. It's the same thing. So keeping, let's say, the 1 as your first element, right? The other variations would be the 3, the 2. Whoa. Oh, yeah, yeah, yeah. What am I saying? With 1 being there, it would just be the other 2 switched, right? So how could you represent this in like, I guess it could be from the 1, you can go to a 2, right? Or you could go to a 3, and then from here you could go to a 3, or you could go to, or over here you could go to a 2, right? I guess this is kind of how you want to approach it. Is you have the original elements, and then you cross that out of your array, right? You have these elements. And for each element, you make a new layer, right? And then each of those elements, you cross off the new one and you make new layers of those. And you keep going down. And what you'll eventually build out is each finger or whatever is going to be something I can return, right? So it would be like, um, let me, oh shit. But like, and then from this 2, right? So we're not going to include the 2, so we can go to 1 or we can go to 3, right? From this 1, I can only go to 3. And from this 3, I can only go to 2. And then, gotta move this over. Wait. And then finally for this, it would be, I can go to 1 or I can go to 2. And from here, I can go to either 2 or I can go to 1, right? So now we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Yeah. So that's the idea, right? Now how do I flesh this out in code? Would this be, I just want to see recursion, iteration, backtracking with a bit mask. I just want to see, so there's never implements a node class. That's all I wanted to look at. Because on the last one, that was also kind of like the idea, right? Or no, that was on the word search one. So what did we do there? Wait, let me actually go and look. I think it was on tries. No, it was on like an autofill, right? Add word and search. Yeah. Oh yeah, no, this implements a try node. But like, I think this would be a pretty good approach, right? Would be to implement like a try node and have, or just a regular node thing. So here, let me just take this, and we'll go back, and I'll add this. I don't care about it being a word. All I've ever really cared about is, I feel like, just children, right? For each node. Well, actually, let's think about this. How would I return each individual thing? I'd have to return, given the first level, right? I'd have to return this and then all just doing dot right, and then this given dot left, and that would be it. But if we're like at length 4, then these, from this one you could go to like something else to something else, right? So no. Oh my God. How do you implement this? So is there any way that I could take each value of nums and then for each value give it, I mean, because then it would be like, okay, this is a trie node and its children are 2 and 3. This is a trie node and its children is this and this. And so I say, okay, given this trie node, right, and it has 2 nodes, right, I want to go to this node and then, oh, given how many it has, I want to search both of these, right? And then it'll be a recursive thing where it should, no matter how big it is, go up and it should return every single path it took. And that's a permutation. But I'm struggling on like a trie node does seem like it could be really nice here. Right? Because I feel like the trie node, because in a traditional binary tree, right, it's from any given node you only have a left and a right. The trie node kind of allows us to, for any given node, it just has children, which is, well, here it's actually a dictionary, which, like, can I just make this an array? Kind of just want to make this an array, and then it's going to be like, I want to do something where I say, okay, um, root is equal to a trie node. I need to use the bathroom real quick. I don't know. I think we're getting somewhere. I don't know. I am back. So, um, so basically, okay, if I do this and then I say root dot children, damn. How do I even like assign? Oh, maybe that is, yeah, yeah. I should do this as a dictionary because then I can have, yeah, because then I want to actually store the value of the, yeah. But yeah, yeah. So if root equals trie node, cur is self dot root. Like here, so we have a trie node, right? Self dot root equals just a new trie node, and then if cur is equal to that, or we could just say root, then root dot children at whatever. Okay, so I can say root dot children at a equals 1. So if I print off root, should be a dictionary, right? Can I say? No, it would have to be root, not values. Trinode has no attribute values. Can I do root dot children? Nice. So it returns the dictionary with a key of A in 1. Okay. So the idea here is, I mean, it's going to be a depth first search, right? we are going to have a depth first search that's going to take in a root at the very least, right? And we're going to call DFS with root. But let me check that DM real quick. Well, first we need to build it. I assume actually it would be quite stupid. Well, how do I want to? Oh my god. I want something that is going to. So like the root is going to have. Actually, root should be equal to a try node, and then before I even pass root in, right? Root should honestly have root dot children. I feel like this is just like I first want to see. Why is it not copying it? I need to learn backtracking. Honestly, I wanted to flesh out the code for this in just so I like know, and then I'm going to attempt backtracking. So children of permutation, try node, return build. Okay. So in build, there's a node or bank case, no remaining numbers left to add. So remaining is nums. Return the permutation. For num in remaining, create a child node. Child.permutation equals and so this would work. Wow. Okay, I'm just trying to figure out. So for each num, okay, so this is, so we have one, right? We create this into a try node. Or no, we just create child equals try node. Child.permutation equals node.permutation. Now, node is our root. Our root is simply just a try node. Nothing special. It's literally just a try node. Remaining is this. So for each num in remaining, we just create a child, and the child permutation is node.permutation, which is nothing plus the number, so 1. So the permutation is just 1, and the children at 1 is equal to just the child. And then we go through and we say, okay, results dot extend recursively called build on child, and for each number in remaining, right? For each number in remaining that isn't this, so this would be our 2, 3, right? So we'll go through with 2, 3. So the first one is going to be, well, child is going to be what? Like 2. Wow, this is a little weird. Huh. 1 second. All right. I think what I'm gonna do. So I won't lie. I don't get backtracking at all. I don't even know what it is, really. I mean, like, backtracking is probably doing something and then going. Like, I'd assume it's like building something out and then record. But like, that's why I just kind of want to watch the video, and then this is probably the only LeetCode I do tonight, and then I'll work on CLI until the game. So.
Hey everyone, welcome back.
Oh, it's not flickering. Finally, I can actually just.
And let's write some more neat code today. Hey everyone, welcome back. And let's write some more neat code today. So today let's solve the problem. Permutations. I've actually already solved this problem before, but I think I could explain it a bit better, so I wanted to do it again. We're given an array of distinct integers, and we want to return all possible permutations of those integers. So for the record, a permutation of a set of numbers like this would look something like this. We have 3 numbers, so we're going to have 3 positions to fill. For the first position, we have 3 choices. We can pick any of these 3 elements. So let's put a 3 over here. For the second position, we don't know which element we already picked. We could have picked this one or this one or this one for the first spot. But either way, we know we're going to have only 2 elements remaining to choose from to place over here. So there's going to be 2 different elements that go here. And then after we've picked the first 2 elements, this one is already decided. So we'll put a 1 here. So 3 times 2 times 1, we'll have 6 different permutations of this set of numbers. And in order to visualize it, let's kind of draw a decision tree. So let's say that for the first choice, we can choose among 3 elements. We can have 1, 2, or 3. So regardless of which path we take, we're going to have 2 choices. Here we can have either a 2 or a 3. We can't have a 1 because we already picked it. Here we can have a 1 or a 3 because we can't have 2. We already picked it. Here we can have a 1 or a 2, but not a 3. So now it's going to get a bit more simple. We'll only have 1 choice for each of these, and it must be the element we haven't chosen. So here it's going to be 3, here it's going to be 2, here it's going to be 3, here it's going to be 1, here we haven't chosen 2, and here we haven't chosen 1. So now, if you go through each path, we have a permutation. We have exactly 6 of them, and you can see every single one of these is different. So if we could have each of these in an array, this is the result. Like, we've calculated the entire result. Now, the only problem with the way we're thinking about it here is it's pretty easy on like pen and paper to draw this out, but how would we actually calculate this in terms of code? Obviously, it looks like we're using recursion, and it's definitely possible to do it that way, but the way we're doing it right now involves a decent amount of bookkeeping. Because what exactly is the subproblem? Like here, we chose 1, right? So we got rid of 1, and these are the elements remaining. So now we're trying to create permutations with those elements. But here, the subproblem is different. Here we use 2, so now we have these elements remaining, and we're trying to create permutations with those elements. Again, we could do it this way, but it would involve like removing this element and doing some other stuff. So I think a slightly easier way to think about this problem is to really use the idea of subproblems because it makes recursion very, very easy. So let me kind of redo this in a very simple way. Now we're still gonna use recursion, but we're actually not even gonna branch anywhere. So you're gonna see something interesting. Here, we have 3 numbers to choose from. So what we're trying to do is give me all permutations from 1, 2, and 3. But next, the subproblem we're gonna ask is this. Give me all permutations with just these 2 numbers. So we're going to have something like this, 2, 3. And then finally, we're going to ask, just give me all permutations with just a single number. Notice how it's getting more simple as we go down. So watch what the return value is going to be. Well, first, let's go to the base case. If I don't have any elements, from here, I'm going to return up an array with an empty list. Like that's our permutation. We can only create 1 permutation with an empty set of numbers, and it's an empty permutation. So that's the base case, just to keep it simple. And now it's going to stay pretty simple. With just 3, how many permutations could we have? Well, it would look like this. We're going to return up to the parent just a single array with the value 3, because a single number can only be permutated like that. Now it's going to get more interesting. From here now, from this subproblem 2 and 3, how do we solve it? Well, you probably know what the return value is going to look like. It's going to look pretty simple, just like this. So it's going to have 2 in the front, and it's going to have 2 in the back. So 3, 2, like this. So these are the 2 permutations we can create. Now, the reason I'm showing you this way is so easy to calculate. Just watch this. From the base case, all we do is just add 3 to that list. Okay. Now, from here, this was the numbers we're given. We already got all permutations from 3, so now the only thing to do is to add 2. So what we do now with this array, it's a very simple array. It just has 1 element. So we know we have 2 choices, actually. With 2, we can put it at the front, or we can put it at the back. So that's exactly what we do. We create a permutation with 2 at the front, and then we create a permutation with 2 at the back. And then from here, we're going to do the same thing. We have these 2 permutations, 2 and 3. What we're going to do is try to put 1 in every position. We're going to try to put 1 at the beginning. We're going to try to put 1 in the middle. And we're going to try to put 1 at the end. So we're going to end up with 3 different permutations. We're going to do the same thing with this one. We also have 3, 2. It's obviously different from 2, 3, so we're going to put 1 at the beginning, in the middle, and at the end. And if we do this, we're going to end up with 3 more permutations, which is 6 total permutations. And that's obviously going to be the result. And if you're curious, I'll quickly draw out those permutations. Here, 1 goes at the end. Here, 1 goes in the middle. 3, 1, 2. And we're coded up with the base case, which is pretty simple in our case. We're going to have the length of the input. And when it's equal to 0, we're going to return a list with a single empty list inside of it. And so the reason we're using that is because we're only going to have a single parameter, the input list. The idea is that we're going to keep calling the recursive function with the input nums without the first element. So that's the sub problem. Just get rid of the first element from nums, just create a subarray starting at index 1, and that'll give us all the values from nums except the first one. So these are our permutations, like our subproblem. And then we want to, from these, add the current element, which is the number at index 0, to all of these in every possible position. And we're going to store those in another variable, which I'm going to call result. That's what we're going to end up returning from this function. Now, to actually do what I said earlier, let's just go through every single permutation that we have. And for each permutation, let's go through every possible index that we could insert the current value into that permutation. So I'm going to get the length of p. I'm also going to have +1 because we technically could add to the end of the permutation as well. So now, for that permutation p, I'm actually going to create a copy of it because we're going to use this one multiple times. We're going to possibly add a value to it in multiple different places. We don't want to modify the original permutation. We just want to create a copy of it. So I'm going to store that in a variable called pcopy. Then for pcopy, we want to insert at index I the value nums at index 0. We're taking this value, inserting it at this index. We're going to do that for every index, and then we're going to take pcopy and append it to the result. We're going to do that for every permutation, and then the result is going to be here, and then we're just going to go ahead and return. Now, as you can see on the left, this solution works, and it is very efficient. Well, it's about as efficient as we can get for this problem.
Wow, that's pretty nice, actually. So the length of nums is equal to 0. Return an empty list inside an empty list. And that's a recursive base case. And then for p in perms, which is perms is just a recursive call of num on nums, of taking a smaller thing of nums, right? So in the first example, perms is going to be 2 and 3, right? And we say, and then the result's going to be empty. And we say for p in perms, which p is going to be what? If perms is equal to the result of permutate of nums. Okay, so when we get down to the very end, right? So perms is going to keep going until we hit this base case, and so then we'll actually have perms is equal to an empty list and an empty list, right? And then for p in perms, interesting.
And let me just kind of show you how to analyze the time complexity. The idea here is it's going to be easier for us to do it without kind of focusing too much on the code. Remember that how many permutations are we going to have? Well, if we have 3 elements, we had something like 3 times 2 times 1. That is a math equation called n factorial. So if we have n elements in the input, we're going to have this many different permutations. How do we build each individual permutation? Well, to add a single element to a permutation, we're like inserting in the middle. That's how we're coding this up. So it's an n operation. And that's just inserting one element into a existing permutation. If we're inserting n elements into each permutation, we're going to have like an n squared over here. So the overall time complexity is going to be n factorial times n squared, but this is really the dominating factor in the time complexity, n factorial. Space complexity wise, if you're not counting the output, which is just going to be n times n factorial, because each permutation is going to, this is space, this is time. Now you might think, since we don't even branch in this recursion, isn't it possible to solve this problem without recursion? And you're exactly right. The logic is going to actually be very, very similar. Like we're going to start kind of with this as the base case. I think the time and space complexity is going to be the exact same, so I guess I'll leave this here. But this, we're going to call this our permutations, and we're going to get rid of this because we're not going to have any recursion. I want to leave this code here because I want to show you how similar the solution is going to be. Remember, this is the base case. We want to compute like the subproblem. So for every number, I could use like an index I to make it more clear, but we don't need to. I'm just going to go for n in nums. For every number, we want to now add this number to all the existing permutations. That's what we're trying to do. That's the logic behind this. So I'm going to call the new permutations we create with this number the new perms. It's going to be just an empty list for now. We're going to go through every existing permutation, kind of like we did down here, right? Going through every permutation. And now I want to insert this element into every permutation. And I need to do that for every position. So I'm going to say for I in range length of P plus 1, exactly the same as we did down here. And now to that permutation, I want to create a copy of it just like we did before. And then I want to insert into that copy the current element. At index I, we want to add n. So this is slightly different, I guess. It's not nums of 0, it's n. And also, I want to say, let's take this now and add it to new perms. So new permutations, append the end.
I see. Cool. Cool. Give me 1 second. I'm back. I'm sorry. I keep going. Okay, I think I'm just gonna work on the CLI project now. Bro, I'm telling you, every time it gets like later at night, I'm just not in that DSA mindset, you know? Not in it to win it. Okay. Put that away, put that away, put that away. Alright. So I'm actually gonna go a little I'm only gonna probably this video is only gonna be a little over an hour again. Apologies. Because I'm gonna cook before the game, so you know. I didn't want to do that yet. I wanted to do CD, OneDrive, desktop, code, Docker tool. Okay, so we were at. Oh my god. So the questions that we're asking are, how many images do you want to generate? For each image, we say what's the name, what's the base image for your image, and so this should be. So beforehand, I have this checkbox of files. I also want this to be binary Docker image setup guide. So what can I just image questions? So this just goes there. What? Oh, man. One image, image one. Nice. Oh, did it actually make? What did I end up putting? It should actually be in um if it made this, I don't care about this. Or maybe I did. Yeah, Nginx. Nice. Cool, cool, cool. Okay, so another big thing was that no, it does have this as a Docker file. Okay. Because is that what I had in Code Visualizer? Dockerfile dot whatever. Okay. So good, good. Um, Now how is it generating that? Actually, I should look at that. So it's doing from this work directory. See, like work directory. If we go and we look at, let me look at this DM first. 1 second. I have to go in 10 minutes. Okay. I can just reuse this. So code visualizer, login service, front end. So on here we have this, and then we copy everything. So the idea is, honestly, I think for oh wait, no, but it is for file in details. Wait. In details. What the fuck is details? Index and detail and all image details. Where's all image? All image details. Image details. Print off. Uh, console.log file. Give me all that. But then I kind of want it to be like okay. How about in code in Docker tool, right? We have main. Let's also have a new folder called like test, right? And in test we'll have a front end and we'll have a back end. The front end will have an index.html and the back end will have a server.js. Okay, so the idea here is that I can say this, and I want two images. Image one is going to be the front end, and so we're running our front end off of engine X. Okay, this is the thing though, is I can't. I have to write the function to be able to go into that. Expose on port 8000, sure. Number two is backend. I want node and test. Expose on port 80. Yeah, build it for me. Okay, so my front end looks like Nginx, and so then it has. So what is this whole working directory thing? So it's like it's just writing the working directory, but like why? If I go to the code visualizer login service front end, right? It doesn't do any of this. It just copied everything I needed and exposed it to a port and then started Nginx, right? This and then this, the docker.write this should be based off of what is selected here. So based off of your choices, right? Now, did this log shit? Really didn't. So this is the right idea that for each file that is selected. So okay, if I were to go into here, if I were to take this, let's say copy it, go to Docker tool, and then like paste it, um, then go back in the test, go to my front end, take this, go back to Docker tool, paste this. I think I should now be able to, let's just run this on one image. Front end, oh, and let me delete these. I should be able to run this off Nginx and then run it off of this on port this, and then yes, build it. Okay, I still don't know why it's not printing, but anyways. The idea here is going to be, oh, I don't know. Base image is fine. Now in details we should have, so like this, I don't care about this. I need this to be working. And I don't know why this has, so this needs work to correctly copy each file. So the whole idea is going to be when we ask them what files do you want, I need to write a function that is going to take the folder, right? We're going to take the folder and you're able to go into the folder. I still have to add that. Once you can go into folders, you can select what files you want, and then we're going to take every single local address, right, of those files, and we're going to add them into the Docker file we generate, right? So it's going to be copy every single file that they make. And then based on the choice they make up here for the base image, right? Right now it is actually working where we take in details, we do the base image. But also based on the base image, there's a command line that we have to run the actual file. Right now we're just defaulting to this, right? Default command need to adjust to the current base image. Okay. I think once we do that, right, once we have the base image, all things that we have to copy are port and how to run it. That should be good for now. I'm sure there's other things that I'm missing, but should be good for now. So I'm gonna leave it here because I do need to go, unfortunately. I again, these videos need to be better. Like today, the leak code wasn't good, and I mean, I didn't even really write a line of code on this. So apologies, um, but I'm not missing this Texas game, so and I want to make food for it. So yeah, so God, go down. Um, yeah, so yeah, so I need to do better on the leak codes. This backtracking shit just makes no sense to me. So I think I might do some preliminary work on figuring out what that is tomorrow. And then we'll do another two leak codes tomorrow, and then work on CLI Project. Ideally, honestly, as long as I give myself enough time before the like NFL games tomorrow for playoffs, could make like I said, I want this weekend to finish up this. And I do see a light at the end of the tunnel, honestly, for at least a base full stack version of this where I can work on a full stack project, right? The only no, the really good thing about making something where like you can just select the direct files is it's like it's not it's a trade-off, right? It's like you're losing a little automation. Like obviously it'd be amazing to be in your root directory and just say like type in one command and it goes through and makes the images and runs them. But going through and specifying a port, an image, a the files you want for each image, the whole idea is we wanted to automate the process, and that automates the process. That literally reduces it by a lot of time, being able to just go in and press each file you want to an image, what port you want to expose it to, and what image you want to run it on, and that's it. And then it builds out the Docker file and it runs the Docker file. And then also the other thing is I need to build out generate the compose file if the project has connected images. Okay, so that's the other thing, is working on the compose aspect of this. But yeah, other than that, that was it for today, and I will see you tomorrow. Bye.